So this is A2Pure notes, and we are in Unit 5, and we're looking at functions. This is our final example then, so it's example 2. It's a slightly more complicated looking function. The function f is defined by f of x equals 2x plus 1 over x plus 2, and that's for x greater than or equal to 0. Find the inverse function and find the coordinates of the point of intersection of the graphs of f and f to the minus 1. So first of all, to find our f to the minus 1, we're going to let y equals 2x plus 1 over x plus 2, and then we're going to try and rearrange for x. So how are we going to do that? We're going to have to multiply through by our bottom line. So we're going to get y upon x plus 2 equals 2x plus 1. That gives me yx plus 2, y equals 2x plus 1. Taking x is to one side and everything else to the other, we're going to get yx minus 2x equals 1 minus 2y. Factorizing out our x, we have y minus 2 all over 1 minus 2y, and then rearranging, I'll have 1 minus 2y all over y minus 2. Therefore my inverse function is 1 minus 2x all over x minus 2. The graphs of f and f to the minus 1 intersect at the point of the graph where y equals x and y equals f of x intersect. So to find the coordinates of these points, let's write a wee bit about that. Intersect where y equals x and y equals f of x intersect. So therefore solve tenuously. So we have y equals x and y equals 2x plus 1 all over x plus 2. So we are going to eliminate the y, or just put the two equations equal to each other. It's one and the same thing. X equals 2x plus 1 all over x plus 2. Multiplying through, we get x upon x plus 2, 2x plus 1. Move this up so we can see it. X squared plus 2x equals 2x plus 1. Taking everything over to the one side, we get x squared minus 1 is 0. That's just difference of two squares, so it's x minus 1 upon x plus 1 equals 0. And it's, of course, the y coordinates have to be the same because where they intersect. So whenever we have x equals 1, then y equals 1, and whenever x equals minus 1, y equals minus 1. So the points, that's showing where this graph intersects with the line y equals x, and of course where the line y equals x crosses this graph is the same as where the inverse function crosses the graph as well. So it's a very useful technique for sketching graphs in of inverse functions. So we could end up then with that.